Hello friend, in today's video we will learn how we can connect a GPS module with Raspberry Pi. We will see the complete hardware designing of this project. Then we will see how to do the programming part so that we can easily access the GPS data in Raspberry Pi. Then we will see how to monitor whatever the GPS data received from the GPS module to actual Google map so that you can find your location on actual Google map. And after that we will see the programming part of this project. So I request you please watch this complete video so that you will get idea about each and everything about the GPS module and Raspberry Pi connection. So before start the next part, I request you please subscribe my channel. Currently you can see I have 1356 subscriber and my watch hour is 3388. So my to verify my channel on YouTube I require 4000 watch hour. 1000 subscriber is already completed. Thanks for your support, but please watch my complete video so that this watch hour gets completed easily within 1 year. So once you click on the subscribe button, it is not only beneficial for me, it is also beneficial for you, because I have uploaded the more than 40 to 50 video on Raspberry Pi and Arduino, and all projects are very unique and you will definitely learn from me. So please subscribe my channel, please watch my complete video. Thanks for the support. So whenever you plan to start the hardware part, make sure you have Raspberry Pi 3B or 4. You can use any Raspberry Pi. In my project I have Raspberry Pi 3. So whenever you buy Raspberry Pi 4, Raspberry Pi 4 or Raspberry Pi 3, you can see this pin is open and you can not able to find out the pin number of this Raspberry Pi. So I will provide you basic idea behind this pin number. So first pin, that is the you can see this is the LED, and LED side first pin it is nothing but the 1 number pin, then second pin is this one, then third, and then fourth. So odd number pin should be connected at this row, this column, and even number pin at connected this column. So it is very difficult at the runtime you can find out the number, so it is very easy. You can take the one paper and you can draw this pin name as it is, like I have did 1 2 3 4 5 6 7 8, and plug this pin on this Raspberry Pi so that you can easily find out the pin number of Raspberry Pi. So now you can see I have placed my paper on the Raspberry Pi pin, so you can see easily I can identify the pin number of Raspberry Pi, and during hardware connection I can easily find out which pin is connected at which point. Now second hardware is GPS model. So this is the GPS model you can see on the screen. So this is the GPS model you can see on the screen. Whenever you buy the GPS, you will get antenna also with the GPS. You have to connect that antenna at this point by manually. Then after that, on the GPS model you can see there are 4 pins, VCC, RX, TX and ground. So we need to connect this 4 pin with Raspberry Pi pins. So basically this GPS model work on the 5 volt power supply when you connect to the Raspberry Pi. And if you want to connect this with Arduino, you can use a 3.3 volt power supply from the Arduino, but for the Raspberry Pi it's work on the 5 volt power supply. So Raspberry Pi second number pin, that is this pin, second number pin, this first pin is work as a 5 volt power supply, and the 6th pin is work as a ground. So we will connect second and 6th pin to VCC and ground respectively. Then after that 8 number pin of Raspberry Pi work as a TX pin, that should be connected to GPS model of RX pin, and 10 number pin of Raspberry Pi should be work as a RX pin, and that should be connected to TX pin of GPS model. So you can see on the GPS model we have the TX and RX pin also, and this should be cross connection, because when our GPS model sends some data, this will send to the TX pin, and then TX pin Raspberry Pi should receive that data, and Raspberry Pi only receive that data if the TX pin gets connected with the RX pin of Raspberry Pi. So that's why it is cross connection. So and some hardware part you will require some jumper wire, that is female to female jumper wire. You can buy the jumper wire also from the Amazon or Flipkart. Okay, so after that first we connect the Raspberry Pi with the GPS model. So first point is you have to connect the VCC pin first. So I am taking the VCC pin of the GPS model. You can see on the screen the VCC pin, that is the first number pin is VCC pin, and that should be connected to 5 volt power supply of GPS model, that is the second number pin of Raspberry Pi. So VCC pin, this I connected, and this should be connected to second number pin of Raspberry Pi. Then after that next pin is RX pin, So RX pin of GPS module should be connected to TX pin of Raspberry Pi, that is the 8 number pin of Raspberry Pi. Then after that you can see there is a TX pin of GPS module, and this TX pin should be connected to RX pin of Raspberry Pi, that is the 10 number pin of Raspberry Pi. Then after that last pin is ground pin, that should be connected to ground pin of Raspberry Pi, and it should be the 6 number pin of Raspberry Pi. So connect this to 6 number pin. Okay, so in this way the connection is completed. It is very easy connection. Then after that you can plug your HDMI port. Then power supply, the power supply should be 5 volt 2 ampere power adapter, that is a mobile charger also you can use at this side. Then we will connect the USB to to access the keyboard and mouse. And yeah, this enough is a connection of GPS module with Raspberry Pi. Now we will see the programming part of this project. So before start the programming part, we have to install some library into Raspberry Pi to access the serial port of Raspberry Pi. So how to install that library, how to install the Raspberry, how to configure the Raspberry Pi for the serial communication, we will see first now. So first you have to download this notes file, NOTES note file from my Google Drive link, also the final GPS code from my Google Drive link to access the GPS program. And in notes file, once you open, double click on this notes file, this notes file will open. And in this note file I will added some steps to execute, that is command that should be executed to configure the serial communication port in the Raspberry Pi module. So in hardware part we will see that we have connected the 8 and 10 number pin as a RxTX of Raspberry Pi. So how I did know this is 8 number pin or this is 10 number pin. So basically if you want to see the pin diagram of Raspberry Pi, connection of Raspberry Pi, just go to the terminal window, and here you have to type the GPIO read all command, GPIO read all, and after that press enter. So once you press enter, you can see here 8 number pin and 10 number pin act as a TX and RX pin. You can see this one is 10 number pin and this one is 8 number pin. So that we have considered the 8 and 10 number pin as a RX TX in the hardware part. So this is the basic reason behind this 8 number and 10 number pin. After that, to configure serial communication in Raspberry Pi, we have to change some file. The file name is first is cmd line we have to change, and config txt file we have to change. And how to change that file? There is already one article on the Stack Exchange. This is the link for that article. If you open that article, you can see I have followed these 6 steps. Please follow the 6 steps. I also follow the same step, and with this step I easily able to configure the serial communication in Raspberry Pi. So in video I will explain that step one by one each again. So first steps, you can see in the note I have configure I will tell that sudo Raspberry Pi config. So basically this is used to enable the serial communication. You can use the same command, or you can copy this command. Just go to the terminal window and type here, paste, and after that press enter. So once you press enter, just go to the advanced interface option, and once you go to the interface option, go to the serial communication, this one, and after that click on yes button and click on OK, and again go to the finish, just select the tab. Once you press the tab and click on finish, so it will ask the reboot system. I will not do reboot because I already configured the serial, but in your case, if you configure the first time, click on the yes button. In my case I will click on no. So in this way the serial communication enable. If you want to check the serial is enabled or not, just again go to the Raspberry Pi here and go to the preference, then after that go to the configuration. So once you go to the Raspberry Pi configuration, go to the interface option, and you can see serial communication is enabled. If it is not enabled, you cannot see in configuration it is disabled. Manually click on enable button on serial port and serial console, and after that click on OK button. In this way also you can enable the serial communication. So this is the first step, and after that first step, go to the again terminal window, copy this second command, sudo apt get update. First go to the terminal window again and paste the command and press enter, and once you press enter, Raspberry Pi start updating. I already updated, so I will not execute this command. Now next command is Raspberry Pi upgrade. So copy this command again and go to the again the terminal window and control paste and press enter. So once you press enter, Raspberry Pi start upgrading. I don't go upgrade because it's already upgraded in my system. So once you press enter, it start upgrading and it will ask yes or no. Press enter, press Y in that case, and it will take 15 to 20 minutes. Then after that, after this command, next command is sudo this one's copy. So basically what this command will do, it will create a duplicate copy or command line, create a duplicate copy of config file, config backup file, config command line backup file and config backup file in your boot folder. So in case by mistake you change something in future, or by mistake you change something config file, and because of that your Raspberry Pi not start rebooting, it will give some reboot error. Then that time you can do one thing, just remove your memory card, take one memory card reader and attach this memory card into your laptop and delete this whatever the command line whatever you have changed, and again use this backup file after rename this with command line and remove the BP. So in this way you can create a backup file. So this is the safest way, because in my case 2-3 times I have removed something and because of the Raspberry Pi not start working, and with these 2 lines it save my Raspberry Pi OS, because I manually remove the command line by laptop and again recover my command line with this backup file. You please focus here. If you want to recover your backup file, just remove BP and your command line should be this one only. The file name this should be this one. So whatever the file you have, that should be deleted and you should use this this file, backup file. So basically we have created one backup file. After that what you have to do, you have to change add some this line into the config file. So how to open the config file, just go to this sudo nano. First you have to create the backup file with this sudo copy. Before change anything in config backup file in command line file, just create the backup, press enter and it will create the backup file. Again execute the second command here, copy this command, go to the again terminal window and paste here and press enter. So once you press enter, it will create the backup file. I already created the backup file. Now once you create execute this command till here, next command is this one, sudo config txt. So copy this command, just go to the again Raspberry Pi window, terminal window, paste here. So once you paste here, you can see new file will be open, and at the end of file just cursor down, at the end of file you have to add this line. I already added. So at the end of file you have to add this line. You have to copy line from here, from this node file, copy and go to this file again and paste here. So right click and paste. So right click and paste will work here. So this line should be add at the end. You also see enable UART should be is equal to 1 at your case. This 2 line is very important. If it's not there, manually type this line or copy from here, and this line will be created automatically when you configure the Raspberry Pi, enable the Raspberry Pi serial port through the configuration. So this line should be there and this line should be there. So okay, you have added manually here. Then after that you have to do the Control X. So once you press Control X, it will ask save, and then it will save your data. So I will show you once again. Open this file just for your information again. What I will do, I will change some file here, is remove, and again T I have added, then Control X, then it will ask me for the save, then click on yes button, yes, and then after that press enter. So once you press enter, again check that file, that this line is added or not at the end. So how to check, again open that file, and once you open you can see this line is added here. So in this way you can update your file. So next file is you have to configure, you have to reboot your system. So how to reboot system, copy this sudo reboot, go to again the terminal window, and after that once you go to the terminal window, then after right click, paste, press enter. So once you press enter, it start rebooting your system again. I already rebooted, so I I will not do same. Okay, once you configure, once you added this line, disable BT into the config file by using this command. Next line you have to reboot the system by using this line. Now after this one you have to change cmd line.txt file. So what you have to change, you have to remove console serial 011500 or console ttama0 11500 line from the command line. So how to remove, just open this command line. You can see I have opened this command line by using this command, press enter. So once you press enter, at your side after this enable 0 you will find this one, console serial 0 or console ttmy0. so till all in the file, if you find these two lines, just remove this syntax completely from the command line. So this is the way to do. So what I have removed, I will show you from my backup file. So this is my backup file. So I will open the backup file. So this is my current file that I am using, and this is my backup file. So you can see after enable 0 there is serial 0 in my backup file, this one, console serial 0. So I have removed that, completely remove console 0 from my main file. So after that you will get this file. So you have to do same thing in your command line, and then only your serial will start. And after you remove, just save the file by Ctrl X Y enter. And after that what you have to do, copy this reboot command again, go to the terminal window and paste and press enter. So once you press enter, serial will be execute, or serial communication will start in your Raspberry Pi code. So this is the complete syntax or complete command you have to follow if you want to execute the file. If you want to understand the article, just read this article. So for your reference, I have given my command line and config file in the Google Drive link. So whenever you done your changes, just compare with my config file and command line with your config file and command line. So your config file and command line present inside this one / then boot, and here you can find your command line and the config file, and my config file and command line will be present here, command line and config file. So you can compare these two files with your file so that you will get idea about what I have changed. So okay, once you configure the serial port in Raspberry Pi, next library you have to install this Pi NMEA2. So basically this library used for to capture the latitude and longitude from the GPS. So how to install this library, just copy this library, then go to again the serial terminal and type here sudo pipe3 install and that library, control paste. Then after that press enter. So once you press enter, this library start installing in your Raspberry Pi. So once it install, it will give the successful message. So this is again the second most important library you require to install in your Raspberry Pi. I will copy this command because requirement already satisfied. It is giving this message because that library already installed in my Raspberry Pi. So I will copy this command again and add in the node file. So in this way you can update this library. Now we will see the importance of each and every line from the code. How to open the code, it is very easy. Just download my code finalgps.py and double click on this code. So once you double click on this code, this will open in Thorny browser. So you have to open this in same browser. Now we will see the importance of each and every line from the code. So first line is import serial. Basically if you want to access the serial port in Raspberry Pi, you require this library. Then time, if there is any delay in your code, then you require this time library. Then import string. So basically whatever the data coming from the GPS to the Raspberry Pi, it is in byte format. To convert that byte into string, you require this library. Then import Pi NMEA2. So basically this library used to capture the latitude and longitude from your whatever the GPS data, so lat long will be calculated by using this library. Then while true. So basically whatever the code inside this while true, it will execute infinite number of time. So first line is serial.serial. Then port name, we will use this port name of Raspberry Pi. It is serial port name name. Then baud rate is 9600 and timeout is 1. So this is the basic setting when you access the Raspberry Pi serial communication. Then to access the various serial function, we require this variable. So to create that variable, we will use this line. Then after that, data out pinum nm reader. So basically it is a package, and we will use data out. It is nothing but the, you can see whatever the data reading from the GPS, it will collect here, and this will read out. Then after that, it will transfer to the serial pin. And how to that read the data from the serial pin? By using this line, serial.read line, and whatever the data coming from the GPS, store into the new data. Then after that, all the GPS signal having the different types of data. So and the whatever the latitude and longitude data coming in the GPRMC string. So whatever the 100 line of code, whatever the 100 line of data, we have to search the GPRMC string. So how to search that string? If command we will use if GPRMC, that is the it is string found inside this new data or not. New data means whatever the data received from the GPS. So yes, if it's found, then or I will tell you the importance of this line when we execute the real time hardware that point in the next chapter. So then after that, next line is pi nmmea2.parse. So whatever the data coming from that, whatever GPS code, whatever the serial communication, that should be decoded into latitude and longitude. So for that we require this variable, and with that new message dot latitude is giving the latitude number, new message dot longitude, it will give longitude number. We will store into two variable, and we are just printing that one. So very important line from this project is this one, print this nm decode. So what is use of this line, I will tell you. So whenever the data capture from the GPS module, that GPS module having the 1000 number of data, and the 1000 number of data, the GPRM string, the whatever the data starting from the GPRM string, it actually latitude longitude data. And to find out your exact location through the Google map, we will use the GPRM string. And how to find out that string? By using this line. So whatever the data we will print by using this line, we will copy that data and paste into one website. That website is nothing but this one, encoded, MEN decoded website. So in this website, I will open that one. It is very important website. So for example, I can show you when we run the GPS module at this line, we will receive this kind of data, GPRMC, like this data. So whatever data you receive, you have to copy that data from this Sony browser. From here, I will show you later how to copy that one. And after that, you have to paste that line here. So you can see this already the data, some I configure and paste here. So once you get that data, you have to paste here. I will show you later also. So this data should be like this line, GPRMC and some data. So it will give you some idea, and it will decode this line, and this line contains the latitude longitude with your timestamp, with your date also. So for that reason, we have used this line to decode the data in Python program. And here we are decoding data by using the web page. So this line is basically used for decoding the data, and then we will get latitude and longitude, and we are printing. So later we will see this part in actual practical demonstration, and here you can find then your actual location. So this is the complete idea behind this code, behind this project. Now in the 5 minutes, we will see the actual data, and we will check the actual connection, actual position of my location using this website. So you can see Raspberry Pi is connected with the GPS module. Also I have connected the antenna to GPS module. So basically this GPS module having this LED, and this is not a power LED, it is a power status LED. It is actually signal LED. So once you give the power from Raspberry Pi to GPS module, then this LED will not blink. It will wait for the signal from this antenna. So once the antenna track the satellite, then and then only this LED will start glowing. So in case if you have a new GPS module, then it will take more than 15 to 20 minutes to capture the signal, and signal only capture at outdoor only, not indoor. So make sure your GPS module and Raspberry Pi setup must be outdoor or on terrace or something out of home. So this is the idea behind the GPS. So I am waiting for the signal capture by this antenna, so that this LED start blinking. So once the LED start blink, I will show you how this antenna will capture the signal. So you can see now once so you can see once my antenna got the range from the satellite, the red LED start blinking. Now you can see here. Now you can see here the LED start blinking. That means antenna got the range. So now we will connect our monitor to Raspberry Pi to see the actual latitude and longitude. Now I have connected the monitor. You can see I have connected my monitor to my Raspberry Pi through HDMI port, and also there is a keyboard and mouse also connected. Now you can see range also taken by the GPS antenna. So I will run my code now. So first of all you have to download this final GPS code from my Google Drive link and double click on this code. So once you double click on this code will be open, and if you want to run the program, just click on this run button. So once you click on this run button, you can see latitude and longitude also there, and one string is there. So what is important of that string, I will show you. I will stop the code now. So after we run our code, you will find these two output, latitude and longitude. What is this is the current location, and this one string, it is printing from this line, print new data. So what is important of this thing, I will show you. So in programming explanation, I already told you this is one website in which you can find your current location. Just go to that website. So once you go to this website, here you that website asking for this string. So this string you have to pass. So I have already copied that string, what is my current location and the current date. So I will copy this one, and you can see once I go to here and paste that string and press enter, decode. So you can see current location is Shivaji Nagar and current date also 8 April 2022. So this is the current location and time, and the location also you can find here. This is my current location in Pune. So it is giving the actual data, actual location of my home. So this is the importance of this line. This is the importance of this line, and this is the attitude longitude. So in this way we successfully completed the GPS module with Raspberry Pi.